Right. Final review, day 6. This is we're covering the latter half. So latter 4 problems. So it would be 5 through 8 of practice final exam 3. And let's go to the first one. I didn't prepare and didn't actually open it up on my computer before opening this. That's silly of me. Practice final exam 3, problem number 5. Says, let f of x equal 4x minus 4 divided by x minus 2 squared. Ask the question, is there a relative minimum? And if so, what is it? As always, this is very straightforward. Take a derivative. Set it equal to 0. Solve for x. It's a little bit more complicated than that though, right? You solve for x, then you must show is a relative min by second derivative test. It also works to do like increasing or decreasing intervals. That also works. I really like the second derivative test better. It seems to be quicker in a lot of cases. So need f of critical point, f double prime of critical point to be, for relative min to be positive. So you could do increasing, decreasing intervals if you want, but I don't. Could also show rel min by increasing, decreasing intervals. I just don't like it as much, so I won't do it. I don't think you should if you have the second derivative test at your disposal. So let's do this. Let's take a derivative. And the derivative is for the most part straightforward. It's a quotient rule. So bottom d top is going to be 4 minus top 4x minus 4. My bad. D bottom is just going to be 2x. Go ahead and do the chain rule, but you'll notice that multiplying by the derivative of the inside is indeed 1, so it's just 2x. 2x minus 2. So the chain rule is just going to give you a 1 on the inside. Bottom squared, x minus 2 to the 4th power. Okay, so let's just simplify top. That's kind of maybe the way you want to think about doing these ones. So we'll simplify the top over x minus 2 to the 4th. So if we simplify the top, what is that? This is 4x squared minus 4x plus 4 minus, what does that give? That gives 2, I'm multiplying the pieces in parentheses now. This is 4x squared minus 8x minus 4x plus 8. This is 4x squared minus 16x plus 16 minus 8x squared. There's really a minus 12x inside of here, right? Minus 12x right there. So this is really minus 12x is going to be plus 24x. And then minus 16. So that's nice. These cancel. And what are we actually left with? We're left with negative 4x squared. Minus 16 plus 24 is plus 8x. X minus 2 to the fourth. I can factor out a negative 4x from this, and I'm left with x minus 2 over x minus 2 to the fourth. So you'll see that actually in here, that cancels with that 4 and makes it a 3. And so that actually gives us negative 4 times 1 over x minus 2 cubed. Negative 4x. Okay, so if this is equal to 0, right, I'll write it. There are all sorts of ways you can think about having this equal to 0. But solving for x now, go ahead if you want. You can certainly multiply both sides by x minus 2 cubed, but that's not doing anything to the left-hand side. So that gives you 0 equals negative 4x, and then if you want again, you can divide both sides by negative 4. Oops. You could divide both sides by negative 4, and all of a sudden give yourself x equals 0, or you can just like look at it and notice that x equals 0 works. So this is your critical point. Now we want f double prime of 0 to be positive. So we need to find f double prime of x, and we just I would use this definition of the derivative here. Right, this is f prime of x equals that. So I'm going to use that definition here. Negative 4x over x minus 2 cubed. That's going to make it easier for me to actually take the second derivative. Once again, it's a quotient rule, right? So bottom d top is negative 4. Minus top is negative 4x. D bottom is going to give me 3x minus 2 squared, all over the bottom squared, x minus 2 to the 6th. Okay, we could simplify this. But we just care about the value at a point. F double prime of 0. There we go. Make sure that you can see what we're supposed to be doing. Oh boy. F double prime of 0. So just evaluate. F double prime of 0, by our definition above, is negative 2 cubed times 4 plus 4 times 0. That's going to be helpful, times 3 times negative 2 squared, all over negative 2 to the 6th. So negative 2 cubed is positive 8, so this is a 32 on top. 32 on top, and I believe that's 64 on the bottom. Let me do that quick in my head. 8, 16, 32, 64. Yeah, 64. So this is 1/2, and that's certainly positive. So you say hence Relman. Hence, the point 0, f of 0, which is equivalently 0, 4 times 0 minus 4 divided by negative 2 squared, 0 comma negative 1, is a relative min. There you go. Pretty straightforward. The one on your test is going to be just as straightforward. I don't want to do anything tricky with you guys on this one. I just want to know that you can take two derivatives, use the second derivative test, find relative mins or maxes, depending on what I ask for. All right, problem 6. Let's look at that one. Problem 6 says, I better call it problem 6 so you guys know where I'm at. Problem 6. Let f of x equal x and g of x equal x square root x squared plus 1 over 5. So that looks a little bit ugly, but we're going to see it's not the end of the world for sure. It says the question, what is the total area bounded by f of x and g of x? So just as before, you can see last week's lecture videos if you want to see the specifics of the steps that I'm going to perform. But basically everything boils down to is that the total area is equal to the lower intersection point to the upper intersection point of the top curve minus the bottom curve. Dx. And so our two steps is find intersection points, which happen by doing f of x equals g of x, solve for x, and then step 2 is determine which curve is top versus bottom and where. I guess there are 3 steps then. So step 3 is evaluate the integral above. All right, so let's just do step 1, find the intersection points. So we just set f of x, which is x, equals, make sure that you guys can see this here, f of x equals g of x, but that's the same as saying x equals x square root x squared plus 1 divided by 5. And I'm gonna square everything right away to get rid of the square root. Generally, if you can get rid of a square root, you want to. You just want to make sure that the math you're doing is correct to actually get rid of it. So this is x squared equals x squared plus 1 over 5. Or really, this is 5x squared equals x to the 4th plus x squared. You simplify that out a bit. And what is that? That's 4x squared equals x to the 4th. Okay, so you guys would like to cancel, I mentioned this a few times, want to cancel x squared from both sides. And you can, but just remember x equals 0 is a solution then. Right, if you're canceling x from both sides, that clearly means that x equals 0 is a possible solution. Okay, so we cancel both sides with x squared. So those are gone, and then over here, x squared, that's gone, and that becomes a 2. So this becomes 4 equals x squared, and that one's happening when x equals plus or minus 2. And of course, we have this, this 0 nonsense there. Okay, so these are your points of intersection. These are your intersection points. And there are 3 of them. Let's look at a graph. So go ahead on the exam, use Wolfram Alpha or your calculator if you know how to graph with those. So what do these actually look like? Well, f of x is just x, so I think everybody can manage to graph that one without Wolfram Alpha or a calculator. But g of x is a little bit more special. G of x actually looks like something like this. So these points here, this is at 2, 2. This is at -2, 2. And this is, of course, at 0, 0. Make sure we know that the red one is g of x. Okay, so now is where things get, you know, a little bit different, because our top curve and bottom curves change at 0. So I should say that here. Notice top and bottom curves exchange places at x equals 0. So step 3, I kind of skipped step 2. So step 2 is right here. Step 2, you kind of want to graph. So top and bottom curves exchange places at x equals 0. So f of x equals top for x greater than 0. G of x equals top for x less than 0. That's just what we want to remember here. Bottoms are opposite, of course. Okay, so then this TA, total area, if I'm doing lower intersection point to upper intersection point, of top curve minus bottom curve dx, then this actually gets split into 2 integrals. So I have the integral from -2 to 2, -2 to 0. And we said when x was less than 0, g was on top. So top curve minus bottom curve dx plus integral from 0 to 2, top curve minus bottom curve. Oops. Thinking too much as I'm speaking. Dx. Just to specify this more, this is the top. When x is less than 0, and this is the top when x is greater than 0. So that's just how we want to think about it. And I guess I'll add these in regardless. This is bottom. X is less than 0. Bottom when x is greater than 0. I'm going to say this now, but you don't have to use it by symmetry, this is just 2, 0 to 2, f of x minus g of x. It's just going to save myself some time. Look at the graph. It's clearly very symmetric. This is the area we're looking at, right? The green part. Clearly symmetric, so area is equal twice area from 0 to 2. This is the first one is area from -2 to 2. So that's just your symmetry helping you out. I don't want to perform the integral twice, is all I'm saying, because it's the exact same integral. Of course it is, because it's symmetric. So I'm gonna do it this way. So what is this? This is 2 integral x minus x root x squared plus 1 over 5 dx from 0 to 2. Okay. And I'm just going to split this up as 2 separate integrals, because why would you waste your time doing it any other way? So x dx minus, and now I'm going to call this 2 over root 5 integral 0 to 2 square root x squared plus 1 dx. And we've gotten to that point, but I feel like I have to mention it again. Notice how I simplified this. Notice how I simplified before taking an integral. So just simplify all your stuff before taking an integral. Honestly, it simplifies farther, so we'll do that here even. 0 to 2 x dx minus 2 over root 5 integral 0 to 2. This is really x squared plus 1 to the 1/2 power. And now it looks clear. This is very clear that there's an x there. There's an x in both these cases, right? X and x. Okay, so this is very clear. For u sub and what u equals, because u equals parentheses, right? That's exactly our priorities. So let's do that. U equals x squared plus 1. That means du equals 2x dx. And we have an x in the integral instead, so we're going to say du over 2 equals x dx. And so that gives us 2 x squared over 2. I'm just computing the integral of the first one here. Make sure you guys know that. That's that one. X squared over 2 from 0 to 2. Minus, now I'm going to do this one with u sub, right? So 2 over root 5 integral in u sub version. This is u to the 1/2 du over 2. Because, I'll line these up for you so you can see them all. So if that's u, then that's u. And du is this piece, du over 2, right? Okay, so that's where u squared and du over 2 come from, or u to the 1/2 and du over 2 come from. So this is really x squared from 0 to 2 there, minus the 2's cancel over here. You get 1 over root 5 integral u to the 1/2 du, because I've canceled these 2's. X squared, if I evaluate that, that's 2 squared minus 0 squared, minus 1/5, 1 over root 5, u to the 3/2 Maybe I should have written that differently. This is a power rule again. U to the 3/2 over 3/2 from 0 to 2. So this is 4 minus 2 over 3 root 5 u to the 3/2. And that's not from 0 to 2. That's my bad. That would be, we have to use new u bounds if we want, or we can convert to x. X squared plus 1 to the 3/2 from 0 to 2. And so this is 4 minus 2 over 3 root 5. Rewrite that because that was poorly written. 2 over 3 root 5. And then this piece gets the fundamental theorem of calculus goes in two separate terms. So this is 5 to the 3/2 minus 1 to the 3/2. And 5 to the 3/2, go ahead and use your calculator if you don't want to simplify that perfectly. 4 minus, it's really 10 root 5 over 3 root 5 minus 2 over 3 root 5. And this becomes a plus because I distribute my minus sign. Those cancel, and I get 4 minus 10/3. 4 is 12/3, so that gives me 2/3 plus 2/3. There's a root 5 in the bottom here. And that's exactly what the answer looks like if I factor out a 2/3. 1 plus 1 over root 5. So there you go. That's the answer the exam gives. You don't have to do it by symmetry if you don't want to. Remember, I always do that. Have to use symmetry if you don't want to. It just saves you time. Okay. Move on to problem 7. This is once again one of those crazy ones about integration by parts that I keep asking you guys. I can't guarantee that it's going to be an integration by parts problem on the actual exam, but if you see a piece, I'll say this: if I'm giving you a piece that looks like integral, some bounds here, I'll just call it x0 and x1, some function of x dx equals a number. So if I give you that in the statement of the problem, it's integration by parts. Basically because this sort of a piece would show up in an integration by parts problem. So just keep that in mind. If I decide not to give you a piece like that, that would be the case where it's not integration by parts. If I'm giving you a piece like that, use integration by parts. So in this case, it says, let h of 0 equal 10,000 and h of 1 equal 2. Further, integral from 0 to 1, x, h of x, h prime of x, dx equals 1. Question is, Q, what is integral 0 to 1 h of x squared dx. This is a really weird way to write the problem, but it works, and it's kind of startling that it works. So I say it's integration by parts just because of this piece and what I had just told you. So we want to think about that piece and this piece. So by what I said above, this is integration by parts. And keep in mind, if I don't give you a piece like this, that doesn't mean it's not integration by parts. So I'll say it's not necessarily not integration by parts. So just because I haven't given you a piece like that doesn't mean it's not. But when you do see a piece like that, it for sure is. So we see a piece like that, makes this integration by parts. The real question is, okay, for integration by parts, how should I choose u and dv? It turns out the priorities don't do a great job here. Priorities do not do a great job here. You could go through them if you want. What I'm going to look at instead so I look at this piece that this one, x, h prime of x, h of x, dx, 0 to 1. And I know this needs to come from the integral v du term of integration by parts. So that's what's going on here. So I need to link this with that. These terms are they're playing the same role here. So if this is coming from the v du term, do I see a du is like a derivative. So is there a derivative in this piece? Yes, of course there is. Cool, so we would choose, so we can try, this is an important word, so try du equals h prime of x dx. Well, that would make u equal h of x, which, if u equals h of x, then v equals everything else, or dv equals everything else, which in this case, since our integral, the integral we're looking at is h of x squared dx, that would be, actually this is h of x dx. So then this would be integral u h of x dx. So then dv would have to be h of x dx. And if dv equals h of x dx, then we're going to find out that we get into trouble. So dv equals h of x dx, which would give us v equals the integral h of x dx. I include this piece here. Okay. I want to make sure you guys know where all this is coming from. So this u, let me do it in red. That and that, so that's why those are getting subbed. So dv equals everything else. That is coming from this. Okay, so do these choices. Give that this term that I gave, 0 to 1, x h prime x h x dx. Okay, maybe I swap my primes. Equals integral v du. No. Does not work. You'll notice that integral v du, if the above is right, then integral v du would actually be the integral of h of x dx. Du, I guess, was h prime of x dx. This is not right. Very bad. Not right. Okay, so we need a different choice. Of du from this integral, 0 to 1, x h of x h prime of x dx. You guys are going to think this is crazy when I put it down, but let's try. If h prime didn't work, let's try du equals h of x h prime of x dx. Then u equals the integral here. And actually, this is integrable. This gives me h of x squared. You say, how in the world? This is just u substitution. With u equals h of x. And so I'm going to call it u tilde sub because we don't want to get our u's confused, but that's why that's true. And then all of a sudden things start making sense because, okay, if this integral h of x squared dx equals integral u dv, then dv equals x, dv equals dx, everything else, equals dx, so v equals x. Then all of a sudden, what do we have? We have u equals, and recall, u equals h of x squared du equals 2 h of x h prime of x dx. Put that underline. Bam. Okay, so this was h squared over 2. Doesn't matter. Either choice is fine. H of x squared over 2, if du equaled everything else, then it would just be 2 dx. So it's either one's the same. So let's actually, sure, we'll do that. H of x over 2, so this is actually 2u dv. So then dv equals dx over 2. 2 dx. Make sure I'm doing this right. This equals 2u dv, or sorry, equals 2u dx. Yeah, that's why I'm doing this wrong. 2u dx. So dv equals everything else, equals 2 dx. v equals 2x. u equals h squared over 2. There you go. That's maybe a safer way with the way that I introduced things earlier, and all of a sudden this version works. Why does it work? Let's do it. uv minus integral v du equals uv h of x squared over 2, v is 2x, so that just gives me x h of x squared, minus integral v du, 2x h of x h prime of x dx. Okay, but if I'm evaluating these at bounds, at 0 and 1, what does this give? That's actually x h of x squared at 0 and 1 minus 2 times the integral 0 to 1 x h of x h prime of x dx. And all of a sudden I know these values. This equals 1 from problem statement. And over here, this equals, remember, h of all the way up. H of 0 is 10,000 and h of 1 is 2. So if h of 1 is 2 here, this is 1 times h of 1 squared minus 0 times h of 0 squared. So that term's gone. So this is just 2 squared equals 4. So I end up with 4 minus 2, which gives me 2. This is the answer the exam gives. There you go. Pretty crazy, but not out of this world. Once again, I'm giving you harder problems than what's going to be on the final, just to get you all prepared. And we saw in this case, if you try something and it doesn't work, try something else, and then, you know, it'll probably end up working. Okay, let's go to problem 8. It says, your dog likes balls so much that their happiness increases by 3 b squared happy units for each extra ball they have. Your dogs like cubes so much that their happiness increases by 2 c squared happy units for each extra cube they have. A ball costs $3 and a cube costs $4. You have $22 to spend on these toys for your dogs. How many of each toy should you buy to maximize your dog's happiness? Okay, so we want to maximize happiness. Bam. This is an optimization problem. So everybody's screaming at the screen. Take a derivative. Set it equal to 0. Solve for the variable. So let's do that, but of course, we need a function first. Need our known unknown functions first. So let's just talk about the known one. Known here is the $22 that I know I can spend. Right, that's a known quantity. $22, I have that much money. That's as much as I'm going to spend. So we have some cost equation that depends on the number of balls and cubes that I have, and that has to be equal to 22, and it costs $3 for a ball, and it costs $4 for a cube. This is the cost of a ball, cost of a cube. And of course, this is the total money to spend. Great. So I can solve this for either variable. Let's solve it for b, why not? So 22 minus 4c equals 3b. Divide both sides by 3, we get 22 minus 4c over 3 equals b. Sure. There you go. There's our first equation. It's really step one in these sorts of optimization problems, kind of. And then we have our unknown equation. Is what we want to optimize. In this case, happiness of our dogs. And we just saw by reading, it says each ball increases their happy units by 3b squared. And each cube increases their happy units by 2c squared. So then we can use the above. I guess it goes in for b. Plug in. So you plug that in for b and you get h dependent only on the number of cubes you buy is 22 minus 4c over 3 squared plus 2c squared. Or I can simplify this a bit, and this becomes 22 minus 4c squared over 3 plus 2c squared. I've implicitly canceled 1, 3 on top with the 1, 3 on bottom, and I'm left with 1, 3 on bottom there. And then simplify this a bit more. This is 22 squared. I'm just going to leave it as 22 squared. Minus 4 times 22 is 88, times 2 is negative 176. C plus 16 all over 3 plus 2c squared. And I'm going to take a derivative now. Take a derivative, set it equals 0. Solve for c. Let's do that. H prime of c equals, well, really the first term, 22 squared over 3, that's a constant, so that's gone. I then get negative 176 over 3 c plus, this was 16c squared. 32 over, there wasn't a c there. 32 over 3c plus 4c. So you can group those, the 4 and the 32 together. This is negative 176 over 3 plus 4 is 12 thirds, you'll remember, so this is 44 thirds c equals 0. That's 44 thirds c equals 176 over 3, or also known as, you cancel the 3's and divide by 44 is what I'm doing here. 176 over 44. Now, it might not look like this, but 176 over 44 is exactly 4. So there you go. I've chosen numbers that work again. And okay, so we say c equals 4, so 4 cubes. And how many balls then? Well, we go up to our equation. B equals 22 minus 4c over 3. So say, do that over here. B equals 22 minus 4c is 4 over 3 is going to give me 6/3, or 2 balls. And I circle that, and I compare it to the answer that the exam gives, and I'm wrong. But I've done everything correctly. How in the world am I wrong if I've done everything correctly? Let's look at the answer the problem gives. Seven balls, 0 cubes. Why does this maximize h? Let's look at it. If we remember, h of bc was 3b squared plus 2c cubed. So let's try our ones above. So the first one, let's try this first answer. Let's try it down here. So the first answer was 2 balls, 4 cubes. 3 times 4 plus 2 times, oops, this was c squared, plus 2 times 16 equals 12 plus 32 equals 44. Happiness. What did I call it? Happy units. Happy units. Okay. Let's try this other one. 7 balls and 0 cubes. H of 7 and 0 gives me 3 times 49 plus 2 times 0. 3 times 49 is 147. So 147 is quite a bit bigger than 44. So the answer on the exam is definitely right. Why is our answer wrong? And I'm going to be really mean to you guys right now. Email me if you want to find out. You need to give me your reason why first. And I'll tell you if you're right or wrong. And I'll also tell you the right answer, the reason why. All right. That's that. I hope you can figure out why that's wrong. And if you do, and if you want to find out if you're right, email me. All right, I expect emails, and otherwise I'll see you tomorrow. Bye.